Hi, I'm Janet Johnson, a PhD student at UC San Diego, and I'll be giving you a brief overview on our paper that focuses on referencing in collaborative mixed reality. Mixed reality is a spatial medium that allows physical and digital objects to coexist and interact with one another. It is especially suited to enable remote guidance for physical tasks, and that's the collaboration setting we focus on in this paper. This is where you have a remote helper guiding a local worker through manipulating objects in the real world. If we break down this example, the reference has two parts. The first part is where the person initiating the reference specifies what is being referred to, and the second part specifies where the referenced object is and serves to help others understand the reference. More efficient forms of referencing, like deixis, where one word conveys both what and where, also require the person initiating the reference to know where the object is. And so spatial information, or an awareness of spatial relationships in the task space, is fundamental to the helper's ability to direct attention to an object. Now, mixed reality is a technology that is inherently aware of the environment it's in. And so in our paper, we conduct a factorial design experiment to study and discuss two specific opportunities that it presents to make referencing easier. The first one is to explicitly provide helpers with relevant spatial information. For this, we built a 2D map for helpers that represents the different objects and the worker in the task space. We also created a list interface as the version with no spatial information. The presence or absence of spatial information became our within subjects factor in the experiment and answered whether 2D representations of spatial information will be enough to support referencing. The second opportunity mixed reality provides is to automatically guide workers to referenced objects. Here you can see object 2 is highlighted for the worker when the helper clicks on it. We built a HoloLens application that used visual cues to dynamically direct the worker's attention towards objects in the task space when they were referenced. And the presence or absence of mixed reality guidance became our between subjects factor and helped us understand whether it could enhance performance or reduce the effort required for remote guidance. Now, given that the helper's need for spatial information is primarily used to direct workers' attention to objects, one of the questions we had was if helpers still needed this spatial information when mixed reality guidance is present. Our mixed factorial experiment also helps answer this by understanding how the presence of mixed reality guidance impacts the need for spatial information. We had 40 participants complete a simple task that isolated referencing. Workers wore a Microsoft HoloLens and helpers guided them using either the map or the list in addition to a first-person view. On whether explicitly providing spatial information works, the answer is yes. It decreased task load and allowed helpers to make richer references. And notably, it made it significantly easier to use spatial deixis, despite it being a cognitively expensive process in remote collaboration settings. Mixed reality guidance, on the other hand, decreased task load and increased task performance and the use of deictic pronouns. Something we did not expect was that it also allowed for alternate forms of acknowledgement and task parallelization. As for our last question, mixed reality guidance did indeed impact how much spatial information helpers needed and often made spatial information superfluous. An example impact of this is in the crossover interaction you see here for performance, where in the absence of mixed reality guidance, the map was more effective, and in its presence, the list was more effective. You'll find in-depth explanations and more information about the impact and affordances of spatial information and guidance across a variety of measures in our paper. Mixed reality is already used in domains where expertise is distributed, from car repairs and factory maintenance to surgery. We expect the findings in our paper to help build more optimized remote guidance systems. More specifically, in helping workers understand references, mixed reality guidance is a way to partially offload the referential process to the system and lower the overall communication effort. The paper further outlines what types of tasks and settings could benefit from this. While features like immersive 3D reconstructions can theoretically make referencing as easy as it is in face-to-face collaborations, they limit access to remote experts in very specific environments. Both the methods outlined in the paper allow for experts to provide rich guidance using everyday devices too. Designers and developers also have more freedom to choose the technology that best suit the physical tasks they support. And overall, this makes expertise, which is often scarce, a more scalable and accessible resource. Thank you.